Anne is playing an easy course of mini golf. Her probability of getting a hole-in-one is 0.6. What is the minimum number of games required for the probability of Anne getting a hole-in-one exactly 5 times to be more than 25%? If we interpret these mathematically, we want the probability that x equals 5 to be greater than 0.25. So we know the probability that x being exactly 5 is given by the binomial distribution, and that is to say that the number of games, and we select 5 of those to be successes, so here n is unknown, and we multiply that by the probability of success raised to the number of successes that we require, so that's 5, and then we have the probability of failure, which is 0.4, raised to the number of failures, which is going to be n minus 5, or all the games where he didn't have success. And we want that to be greater than 0.25. So next we can use the calculator to help us answer this problem. On the CAS calculator, go into the main menu. So next what we want to do for this one is set up the equation. So we previously found that we had, if we go into the keyboard and advanced, we had NCR and we had X choose exactly 5, and then we multiply that by 0.6, which is the probability of success, to the power of 5, and then we multiply that by 0.4 to the power of x minus 5. And so it's important to make sure that that power isn't x and then minus 5 out to the side, so make sure that's actually raised to the power of x minus 5. And then what we can do is we can let that equal 0.25, and we can try and solve that. So if we highlight that and we go interactive equation inequality solve, and even if we try to solve it numerically, it's just not going to work. So what we need to do is have a different tactic to how to approach this question. So I'm going to copy that part of the equation and just clear all of that. And what we're going to do this time is, even if we graphed it, we'd find it wouldn't work. So what we're going to do is we're going to define it. So if I paste in what we already had, what I'm going to do is highlight that and go interactive and then define, and we're going to define it as f of x. And then because we have n choose 5 items, the first thing we're going to try is choose 5. Alright, so 5 games and see what the probability is. So that's only 0.077, and we want this to be greater than 0.25. So if we try again and we replace this with a 6, the probability goes up to 0.1866. And now if we continue that, we're going to keep changing this number until we get to greater than 0.25. So from the calculator you can see that when n equals 7, we have a probability of 0.26127, which is greater than 0.25. So therefore we need 7 games to be played to ensure that the probability that Anne gets exactly 5 hole-in-ones to be more than 25%.